Okay, so we're on exercise 4E from the second year mechanics section, and we're doing part B now. Okay, so they're changing the situation and they're introducing a particle of weight 12 newtons at A. So let's draw that again. So there's A, there's B. The supports are still at the same place. So there's a support at C and a support at D. And we've now got the 12 Newton force at A. The 20 newtons is still working through the centre of the rod because it's a uniform beam. And they're the only forces. Okay, and there is potentially a reaction at C and a reaction at D. Okay, but it may well be that one of those equals 0. So let's have a think about that. So this, I think, is why this is a problem-solving question, because part B, you've got to think carefully about what to do. So they're now saying that the rod is about to tilt about C. So if it's about to tilt about C, basically they're saying that this end is going to go down and this end is going to go up. Okay, so how can we show that? Well, let's just try taking moments about C and sort of see what happens. So if I want to take moments about C, I'm going to need some distances. So I was told in the question that that was 2 meters. I'm going to need that distance. Well, if the whole rod is 5 meters long and it's a uniform rod, I know that that's 2.5 meters, so that must be 0.5. So mine is very much not drawn to scale. And then I'm also, let's get rid of that, going to need, where am I? I'm taking moments about C, aren't I? So I want that distance there, which we already had to work that distance out in part A. And we said, well, if that's 2 meters and that's 1 meter and the whole thing is 5 meters, that must be 2 meters. Right, okay, so let's take moments about C. So if I'm taking moments about C, I've got the 12 newtons is going to be pulling that end down, so trying to turn the whole thing anti-clockwise. So that's going to be an anti-clockwise moment of 12 newtons multiplied by 2 meters. I'm also going to have that reaction force at D trying to turn it anti-clockwise. So they're both going to, although it looks like they're working in opposite directions, if you think about how they're going to be turning the rod, they are both going to be turning it anti-clockwise if I'm sort of saying there's a pivot at C. So that would also be an anti-clockwise moment. So that would be the reaction at D times another distance of 2 meters. And if it's not tilting, so let's just sort of assume it's not tilting. So let's say it is in equilibrium. They must equal the clockwise moment. So that 20 Newton force is the only one that's going to be causing a clockwise moment. That's going to be pulling down on the right-hand side. So that's a force of 20 newtons times a distance of 0.5 meters from C. Okay, so let's see what happens. So 24 plus 2 times the reaction at D is 10. So 2 times the reaction at D is minus 14, and then that's where we've got an issue, because that doesn't make sense. We can't have a reaction force of minus 7 newtons. Oh, just move that up a bit. Okay, so it's not possible. So basically what that is saying is, once we've added that 12 Newton force, for it not to tilt, there'd have to be a 7 Newton force downwards at D. Okay, so that 12 Newton force pulling down on that end is so great that we would need a downward force there. That's the significance of why it's coming out as a negative. Okay, and obviously that's not what's happening. It's just balancing at D. So that's not possible. Therefore, what did they actually, let's copy the wording back. So therefore, the rod is about to tilt. The rod would tilt. So the rod would tilt about C. Okay, so it's just that's one way of showing it. I think that's probably one of the quicker ways of doing it.